Hello. In this short video, we will review how to properly use the ECS Inc. International GM-Crit calculator tool. The significance of GM-Crit extends far beyond a mere technical specification. It is a vital element of the crystal that determines the oscillator's ability to reliably and consistently start up and maintain oscillation. ECS offers GM-Crit data for all of our crystals. From the ECS homepage, you can use our parametric search with either specifications or using ECS part numbers. This will give you access to orderable part numbers, inventories, data sheets, all supporting material documentation, including the GM-Crit specific to each and every crystal in our inventory. To access the GM-Crit tool from our homepage, you hover over Resources, then over Design Tools, and then click on the GM-Crit calculator. This will open the calculator page. On the page, you'll find a short version of a white paper, The Importance of GM-Crit. There is also a link to the full white paper listed below. Let's take a look at the tool. To calculate proper GM-Crit, there are 4 specifications that we need to know and enter into the calculator. First, frequency of operation in hertz. Second, C0 or crystal shunt capacitance in picofarads. Third, CL or crystal load capacitance, also in picofarads. And fourth, ESR or equivalent series resistance of the crystal in ohms. So where do we find all this information? It's all listed in the data sheet. Here we have the ECS Inc. ECX 1247B. This is one of our small form factor, low first year aging crystals. It has a possible frequency range from 24 to 80 megahertz. It has a C0 of 5 picofarad. It has a standard load capacitance of 8 picofarad. And the frequency will determine what the ESR is. For today's example, I'm going to go with 32 megahertz. So our ESR is going to be 80 ohms. Start by entering the desired frequency of operation in hertz. If you're not sure what the conversion is, you can scroll down below. We have 2 converters, one for megahertz and one for kilohertz. Type in the frequency in megahertz. That will translate it over. In this case, our 32 megahertz is equivalent to 32 million. We copy and paste that into the frequency box. Next, we have our C0. And if we remember from the data sheet, that is 5 picofarad. And our CL, our load capacitance, is 8 picofarad. And our ESR, based on our frequency of 32 megahertz, was 80 ohms. Hit enter, and the GM-Crit for that crystal specification is shown there. 2.186232652. If you would like a copy of this information emailed to you, you can enter it in the box. And you will receive a full spec of what you have entered in there. The goal of the calculator is to help establish the gain margin or safety factor of the oscillator loop in your design. The transconductance is set by the drive level control in the processor, and together with GM-Crit sets the gain margin of the oscillator loop. A gain margin of greater than 5 will guarantee the oscillator circuit's ability to reliably start up and maintain oscillation. For a more in-depth look at transconductance in GM-Crit, please see the accompanying white paper. We hope you find this crystal GM-Crit calculator tool useful. Thank you.